Hello the internet and welcome back to my channel. Today on the bench we have an Apple Macintosh Color Classic from 1993. This is the last of the compact Macintosh series with a small screen. After this one, Apple released computers with the bigger screen like the LC500 and the Power Macintosh 5200 LC. As the name suggests, this computer features a colored screen. It's a Sony Trinitron. It's supposed to be amazing. I've seen some videos online. I'm looking forward to turning this on and see how gorgeous it looks. Now, why is this Macintosh on my desk? Well, the owner of this computer purchased it and never felt like turning it on. You know, it's like 31 years old, he didn't feel brave enough to turn it on. So he asked me to take a look at it, make sure it works, recap it completely, and do like a full service to all the parts and make sure it works and it's reliable over time. Now, I have been inside this computer already. I just wanted to make a list of components, and I also removed the battery, which hasn't leaked. It's not a Varta, it's a Tadiran, thankfully. However, and I'm leaving you with a cliffhanger here, because there's something within this computer which prevents us from just plugging it up and turning it on. And I'll show you in a second. Let me thank today's sponsor, PCBWay. And now, enough me talking. Let's open up this computer and let's take a look inside. Unfortunately, this Macintosh has been stored improperly. I'd imagine this has been stored in a shed, so it's in an insulated place, and I see quite a lot of rust on the shield around here. The tube is in good shape, there is some rust on the analog board, I see some corrosion on some components, and there's a lot of dirt. But the good news, I don't see anything too major, and the capacitors seem to be in good shape. Now, I don't think I'm going to be able to remove all the rust from this computer, but I think once it's been cleaned and maybe some components removed, I see here what looks like a transistor. It's heavily corroded. I mean, you know, maybe it's better to replace that one. I don't see damage on capacitors or anything, so I'm quite positive that the monitor section and the power supply section is going to be fine. Also, I don't see a refund on this analog board. I think they used a different component, but the analog board and the CRT are not the reason because I said we can't power up this computer. To understand that, we need to take out the motherboard. Here is the Color Classic motherboard. It's quite dirty, as you can see, and as usual with these motherboards, the capacitors have leaked. I can see the juice around the capacitors have caused some corrosion around the ICs. All the pads are kind of dull in color, so those will need to be replaced as a standard thing before thinking of doing anything with this board. Now, what concerns me a little is this area here. Now, the battery hasn't leaked, but I think I'm seeing quite a lot of corrosion on these IC, and I don't think it's this capacitor. I assume, I'm speculating, it could have been gases escaping from the battery like in a natural way, and they just ended up corroding this area. I'm not sure why this area, not the surrounding, but the thing is, this board is pretty dirty. Now, I usually wash the boards at the end of the process. I think I'll make an exception on this occasion and I'll wash it now so I can see exactly what's going on. Also, the fluid I'm using, it's an Electrolube fluid, has some antioxidation, pretty good antioxidation properties, so that will hopefully help with the process. Once I can see exactly what's going on this board, we'll rework what needs to be reworked, and then we'll wash it again at the end to make sure it's spick and span. Lifetime memory. Okay. And the board has come up brand new. I'm always impressed by how well the cleaning fluid works. I'm really happy to have decided to go ahead with the cleaning first, because now I can really see what's going on this board. Now, the good news is that U7, also known as the eGrid IC, it's an MCU looking after the ADB, the startup, is a pretty important IC, is in good shape. The pads will need to be reflowed, but there's nothing major. Usually this area is completely destroyed, and I feel that the corrosion happened because of the capacitor and not because of the battery. It's kind of weird that the seal screen of U7 has come off. If I hadn't found these IC soldered on an Apple board, I would have thought that it was a fake IC, to be honest. U5, which is looking after the sound, is perfectly fine. It doesn't even look there was a corrosion around it, so that is great. To be fair, the most offender on this board seems to be the CPU. Unfortunately, there is a little bit of rust on some of the legs. I don't think there's much I can do. I can try and gently scrape that off. Yeah, unfortunately, when it comes to rust, the options are a bit limited. The next step, of course, is to replace those capacitors. And if you follow this channel, you might know that I'm not a fan of the plier method, which if it works for you, totally fine. I'm just not a fan of applying torque on components on a board. And outside of YouTube, I do some repairs, and these are some of the SMD capacitors that I have replaced over the past 6 months. So I have come up with my own technique, which I don't think is anything special. It implies using 2 irons. I'm warming up the pads simultaneously, and the capacitors come off very easily after that. Now, some time ago, I made a short to showcase this technique, and Adrian of Adrian's Digital Basement left a challenging comment underneath, and he basically said, yeah, try to do that on a board where capacitors have been leaking for years. So the challenge is accepted, Adrian, and just to make this clear, it's a very friendly challenge. Adrian is one of my favorite YouTubers, but I'm actually curious to see whether this technique can work on such damaged pads. So let's go ahead, replace those capacitors, retouch some of those more dull solder joints, and then I guess this board is ready for a test. I normally use my preheater to remove SMD capacitors, but on this occasion I'll just warm up the board a bit with my hot air station. Corroded solder joints won't melt. It's like soldering concrete. So first you'll have to dissolve that corrosion as much as possible. I apply flux and fresh solder to help. The heat will dislodge the corrosion and eventually you'll start seeing shiny solder. Then, after applying more flux, I touch both joints with my 2 irons. Wait a few seconds, wiggle the component a bit to see if it's moving, and use the irons to pull the component out. As you can see, the process was very straightforward here. Then it's just a matter of removing the old solder with solder wick and cleaning the pads. My method to resolder SMD capacitors is to apply solder on one pad only, then apply some flux, as the flux in the solder wire has burnt already when the solder was melt on the pad. Then I use a pair of tweezers to put the capacitor in position and reflow that pad. Sometimes I then reflow the pad again while gently pushing the component down with my finger to make sure it is sitting properly. Finally, I solder the other pads and clean the area. To be fair with you, the last cap on the edge on the board took some extra time. I suppose that big copper area you see on the right is connected to one of the pads, and I did not preheat the area first. But it worked in the end. With the capacitors replaced, I went ahead and reflowed those dull joints. As I said, it's like soldering on concrete. It takes a little time. I apply heat and fresh solder, and I can see the corrosion slowly dislodging from the joints. You want to be careful and not apply heat for too long, or you might damage the component or the pads. But after a couple of passes, all joints look much better. Some pads refused to accept new solder, and I had to use my tweezers to apply some mechanical action and further dislodge the corrosion before I could successfully see some shiny solder on those joints. The process took a little while, as there were quite some components around the board which showed dull joints. But as you can see, it was nothing horrible, and I think I managed to fix all the damage caused by those nasty capacitors. Before I test the motherboard in the system, I'd like to make sure the voltages are fine. As in any compact Macintosh, the voltages, the power supply, is on the analog board, which is also driving the CRT. Now, this computer has a soft start from the keyboard, so it needs the motherboard to actually completely power up. But by watching one of Adrian's videos, I understand that by just apply power without the motherboard, the power supply will come up, but it needs a load like any other compact Macintosh. So I have connected the random hard drive and I'm monitoring the 5 volts line on my multimeter so we can see whether the hard drive spins, and also we can check the voltage and then we can check the 12 volts as well. I have disconnected the degaussing coil here, which is drawing quite a lot of power when a monitor is powered up, and I'm obviously running this through an isolation transformer and the current limiter, so my current limiter wouldn't like it. So for the time being, this is disconnected and it's totally fine. As I mentioned in my intro, this system hasn't been powered up. I have no idea for how long, so lots of question marks. Will it work? Will it come up in smoke? And we don't know. I guess we will know in a second. It's time to power up in 3, 2, 1, go. No. Dead? So the first test was a failure. Now, I do know that I've got mains coming in because I measured the voltage at the bridge rectifier and I do have 340 volts coming out of it. So that is working. So it looks like there's something wrong with the power supply, or hopefully it could be just a connection somewhere. I don't know exactly how this board is interfacing with the rest and how the voltage is coming from the board onto this cable here for the hard drive. So the next step would be to take everything out, inspect everything, and hopefully we will find something simple that is stopping this power supply. It's stopping the voltage from reaching the hard drive. I don't hear any clicking or any weird noises here from the power supply, but my current limiter is telling me the power supply is drawing 35 watts. Which is quite a lot for a power supply which is not doing anything. So anyways, let's take everything out and we'll move from there, I guess. Usual disclaimer applies here: don't work on CRTs and or power supplies if you don't know what you're doing. There's high voltage with these devices, even with the unit unplugged. The analog board is out and there is a connector there towards the front of the computer. I'd been wondering how the board was communicating with the rest of the system. Now, what I think happened is that earlier on, while I was moving the Macintosh around, I unintentionally pulled the board out and I didn't realize it was actually plugged into something. I thought it was just sitting there. So I might have pushed it back, but I don't think I have fully pushed it back in. So probably hopefully the power supply was working. It's just the voltage was not reaching that connector, which is in turn connected to that wire that goes to the hard drive. So what I'm going to do, I'm going to maybe spray some contact cleaner and I'm going to reassemble everything, push the board fully in, and we'll try again and we'll see if it works. Take 2, I'm somehow optimistic about this. Let's give it a go. Will it work? 3, 2, 1, go. Oh, it's still not working. This time it's not working for real. So I'm getting a little confusing information from the internet and friends and everything, as these boards, apparently they are not supposed to power up when they are just plugged in with no logic board. They are only supposed to power up when the logic board is sending the power on signal, which makes sense. However, I watched the video from Adrian and I also found some other posts online saying that the power supply with no logic board and no hard drive will click, as in I'm protecting myself because there's no load, and with the hard drive it will power up itself nicely and you have 5 volts and 12 volts. So I do not know, but that being said, the board is out and capacitors. We have some damage caused by leaky capacitors, so I would say, regardless of how this board is supposed to work, there's no point in testing any further. We need to fix this first. I would say once everything is clean and probably reflowed and some traces fixed, it's probably salvageable. That being said, the whole board is not in a great shape. The whole computer is not in a great shape. So, I need to check with the owner what they would like to do. But obviously, we need to do a full recap of this board before we even think of powering it back up again. And we need to do quite a lot of scrubbing everything, and I would say probably some components will need to be replaced just as preventive maintenance, as they are obviously corroded and in need of a replacement. So let me start working on this board, and I'll see on the other side when this board is going to be completed. The Analogue board is a single-side board, so it's easy to swap all those capacitors. There are quite a few though, so the process took a little while, but nothing that can't be done while listening to music or watching some YouTube videos. Once the capacitors were removed, I could see the puddle of electrolyte left behind. That took a little time to mop and rinse. After that, I removed the corroded solder mask from the affected areas at the back of the board and applied a new solder mask for protection. Nothing was corroded beyond recovery and everything went well. Out of curiosity, I tested some of the leaky capacitors, and surprisingly they were still testing good, though a 1000 microfarad I tested was completely dead. But it wouldn't be the first time where a capacitor tests good on my instrument, but refuses to work when in actual operation. A big thank you to Bruce from Brankus Creation, the maintainer of recapemac.com.au, for making this nice PDF which helped me in keeping track of the capacitors and their respective polarity. Bruce's channel is linked below, take a look at his videos. Despite the warning in Bruce's PDF, I managed to order the wrong 3300 capacitors. They're too big and they don't fit very nicely. I've botched a couple for now, but I'm expecting some appropriate replacement soon. I am also replacing this component. It's a super fast rectifying diode. It works, but it might not last for long. And I'll also go ahead and replace these two optocouplers, which are too corroded for my taste. I think the Analogue board is ready for a test, but once again I don't feel comfortable in just sticking the motherboard in and press on and see what happens. I really would like to test this Analogue board out of the case like a standard power supply. Now, as I mentioned, this motherboard will not power up unless the motherboard is instructing it to power on, and for that there is a specific pin on the motherboard itself, which is called the Shutdown Enable pin. For the Analogue board to turn on, you need the Shutdown Enable pin pulled high by the motherboard. Now, there are two different schematics for this board. I think there are two different revisions of this logic board. One of the schematic is much more modern and it comes with quite a lot of information and details on how the board works. The other one is very old-fashioned, it doesn't really say much. So I'm blending all the information I found on these two schematics to try and understand how the motherboard is turning on the logic board. My understanding is that the Shutdown Enable signal is coming from the egret IC, which I said at the beginning is pretty important IC, and when the power on button is pushed on the keyboard, there are a couple of pins on the ADB connector here which gets shorted, and the egret understands that the power supply needs to be turned on. This is pin 26 of the egret, which is going straight to the connector here, to the edge connector. Also, but I'm not too sure about that, I believe the power supply is outputting some sort of 5V standby when it's powered on, and that's going to this little IC here, U8, and I'm not entirely sure what it does, if it also powers something there, but that's my understanding. So to trace these signals back to the Analogue board, what I've done, I have wired these two wires here. One is yellow, one is red. The yellow one is the shutdown signal that is going from pin 26 straight into the edge connector here. And the other one is what I feel is going to be the 5V standby. I'm just curious to see whether there is something coming out of the Analogue board as soon as it's powered up, regardless of what the shutdown signal is. So what I'm going to do, I'm going to fit the motherboard back into the chassis and then use my multimeter and trace where the yellow wire and the red wire are going onto the Analogue board connector, which is a different shape than the logic board one, so it's definitely not going to be a one-to-one correspondence. Once I'm comfortable with which one is the pin which needs to be pulled high in order for the power supply to start, I guess then we can actually do a test. Right, with everything out of the case, it's actually much simpler. So what you see here is the logic board connector, edge connector, and this is called the J13 on schematics. And the first part here is for power. The second part here is split in A and B, and I can see that I think it's A, at least the bottom part is going straight to the hard drive, 100%, and the top part is going to the analog board. And I can see that this is not being used 100%, so it's only crimped up to here, but it's going 1-to-1 up to the analog board connector here. So the analog board connector is a bit shorter, but it's going to be 1-to-1 wired to J13. I think it's B. I think that's the bottom part because this is upside down. The third part here, the bottom part is going straight to the floppy drive. The top part is partially going to the front panel here for these little buttons here. So everything is going to be much simpler now. I can still put everything back together and just buzz the wires just to be on the safe side. But clearly I can see that if I'm checking, say, the 10th pin from the left here, it's going to be the 10th pin on the analog board at the same time. So it's simpler than I thought, but I like having this out of the case because now I can actually put everything together and do a few more tests. Logic board and analog board are connected with the chassis, and I'm connecting the multimeter to the red line, which is my 5 volts, and that's supposed to be pin 10 on the logic board. On the logic board you have the odd numbers on the top and the even numbers at the bottom, which means the pin number 10 is going to be like 2, 4, 8, 10. So it's going to be the 4th pin from the side. I have a little resistor pin here to get into these little slots, and I'll see if I have continuity with pin number 5. Right, I don't see continuity with pin number 5. Let's try the yellow wire, which is going to pin 14. So that's going to be pin 7 on this connector here. And no, I haven't got continuity, so maybe I'm doing something wrong. Let me remove the analog board for a moment and let's probe the connector, the female connector directly. So this is pin 7, so this is actually working. It looks like there might be an issue of connection issue between the connector here and the analog board. So that's actually good to know because it means that probably this would have never worked. Now I'm looking at this connector here. It's actually pretty discolorated here where the power is. Since we are here, let's also try and trace the 5 volt standby line, which is supposed to be on pin 5. Yeah, it's working. So my logic is sound. It's just either this connector or the one internally here is not in the greatest shape. And if I'm seeing that right, I think this connector is not in the greatest shape, but it's golden plated. So I think it's just a matter of cleaning it, and hopefully that will sort out our problems. That's the 5 volts line, working totally fine. Let's check the shutdown signal. Working totally fine. So, well, I guess this Macintosh would have never worked without cleaning that connector. But now we know which are the pins which we need to work with to power on these power supply. Right, I think I'm ready to give these a go, and please don't do this at home. This is quite dangerous and I don't feel too comfortable myself, but anyways, we'll see what happens. I have soldered a few wires here. I have the black one is the ground and the red one is what the schematics call the treacle line, and I'm hoping is the 5 volt standby, and the yellow one is the shutdown line. Now the analog board is in the chassis, so I have plugged a hard drive here which is connected internally through the power connectors here. Just in case the analog board decides to come up to life, as I've seen in some videos, you never know. But what I'm doing right now, I'm actually not doing anything to the shutdown line here, but I'm actually probing the what's called the treacle line, and hopefully I'm gonna get 5 volts out of the board, even though the board is not doing anything. And then I can use that 5 volts to pull high the shutdown line and hopefully power up this board. Now, obviously, because I haven't got the CRT connected, the anode lead is free to go anywhere. I don't think the flyback is gonna start because there's no video signal coming, there's no sync coming, so nothing should really happen. But just to be on the safe side, the anode lead is very well insulated under this glass jar and on some wooden surface. That should be enough. So if everything goes to plan, we should see 5 volts here on the multimeter, and if things are going even better, the hard drive might spin up as well. I'm ready to power up in 3, 2, 1, go. Whoa! The hard drive is spinning! 5 volts! It's working! It's actually working! Wow! It is working. So the board is somehow working without the shutdown signal. So it was definitely a capacitor problem before. We got 5 volts standby. We got the hard drive. I would say we can check 12 volts and 5 volts, but the hard drive is working. So this is working. It freaking works. Let's test the voltages of the hard drive. Let's begin with 12 volts. Ooh, okay, that's not great. It's 10.6. I think it's adjustable here on the board. We'll take a look in a moment. And 5 volts is 4.9. That's kind of interesting. There are a couple of trimmers here on the board, but 10.6 is definitely too low. Now, before I invest too much time into troubleshooting this 12 volts line, I think I need to test everything fully reassembled with the motherboard and the CRT. This is an old power supply, an old Apple power supply, and we know how those power supplies can be fussy without the correct load. Before we reassemble everything, I still would like to test the Shutdown Enable pin. Now, we didn't need to use it as the power supply actually powered up by itself, but because we spent a little bit of time troubleshooting how that line works, why don't we try the opposite? So instead of pulling this line high, which would tell the power supply power on, we can pull this line down, so to ground, to tell the power supply do not turn on. So what I've done, I've got the Shutdown Enable line connected to a 10 kilo ohm resistor, which is then connected to ground. So this is pulling the line low. And when I apply power, the power supply should sense that the Shutdown Enable line is low, so it shouldn't really power up. What I'm hoping to see is to see 5 volts on the multimeter, which is connected to the 5 volt trickle line, which I'm hoping is the standby 5 volts line, but we shouldn't be hearing the hard drive spinning. So let's see if this works as expected. Let's apply power. In 3, 2, 1, go. And yes, we got the 5 volts trickle, which is definitely our standby voltage. The hard drive has not spun up. So that is great, that works as expected. Now let's reassemble this and actually test the motherboard and the CRT. The RAM sticks are not in too bad shape, though some of the contacts need a little bit of attention, so I'll use my fiber pen to try and get rid of that corrosion, and then use some maybe contact cleaner, scrub a little bit, polish it off, and hopefully that will be enough. The fiber pen didn't produce the expected result, so I went ahead and re-tinned the pads. Heat dissolves the corrosion, so with 1 or 2 passes I managed to reach a very good result. Now I guess it is time to replace the battery on this motherboard. I'm not entirely sure whether the motherboard will actually do anything without the battery. Now the old Adrian here, which is expiring in 1996, I believe is completely flat. It is. It's completely dead at 0.036 volts. So thank you, Adrian. You've done a good job and you haven't destroyed the board here. Now, I believe these batteries here are still available, though I believe they might be a bit expensive. So on this occasion, I went with one of these. This is called the CR 2032 toaster. It's a free project and the link is down below in the description. As usual with my project, I had this manufactured by PCBWay, the sponsor of this video. This is a free project. All you need to do is to find the Gerber file, upload it on PCBWay.com. The website is well made, it's very easy. All you need to do is change the color of the PCB if you really want, choose a postal service, and the PCBs will be delivered at your place. I can definitely vouch on the quality of the PCBs, as if you follow my channel, I use PCBWay for all my projects and never really had a complaint about it. These are even golden plated because I thought there's a battery in it, there's some contacts happening, you don't want to have any oxidation or anything in the way at such low voltages. If you have other projects, don't forget that PCBWay can also provide 3D printing services, metal sheet fabrication, and also a new service called the UV printing, where you can print your own picture on a PCB. So, the imagination is the limit. Take a look at PCBWay.com, the link is also down below in the description. Let me thank PCBWay for sponsoring this channel. Their help makes these videos possible. Now, the next step with these holders would be to solder this little metal bracket here, which holds the battery in place. So let's solder this up and hopefully then we can test this motherboard. Alright, I've got everything back together. The Fluke is connected to the 5 volts line, the Kaiwitz to the 12 volts line. I have a hard drive connected to power, but not to data. So if this works, I'm expecting the question mark. If it doesn't, we will see. Obviously, I got the motherboard plugged in, so when I apply mains power, the system should not power up by itself, but it should wait for the on-off button here on the keyboard. So let's feed mains to the Macintosh in 3, 2, 1, go. Okay, nothing really happened, which is totally expected, and hopefully it will now start up when I press the on-off button here on the keyboard. Ready for that? Let's give it a go. 3, 2, 1, go. Yes! Wow! We got the bong, we got the hard drive, I had high voltage, and... do we have a picture? Yes! There is a picture! It's very dim. But there is a picture. I saw a flash, there's another flash, multiple flashes. That's a mouse! Oh, look at that! This is actually working! Would you believe that? We got the question mark! The Macintosh is working! I can't believe this. Look at this thing! It's working! I am super impressed. The power supply is working, CRT is working. The motherboard, well, it's doing something. It's not completely dead. I was not expecting that. I did notice that the 12 volts was not being read. I just patched something pretty badly at the back. So let's try again. It should read now. 3, 2, 1, go. Okay, so as before, we got the voltages a bit too low. So the 5 volts is only 4.8 and the 12 volts is 10.7, which is definitely too low. Now, I can't really find anything on how to adjust the voltages. There are 2 trimmers on the board and I'm assuming that those are to adjust voltages. So I'm assuming that by the time 4.8 volts is brought up to 5 point little something, this is going to be a more acceptable 11 point something, which is going to be totally fine for 12 volts. Let me try and adjust the voltage. Well, I managed to adjust the 5 volts to 5.2, which I think it's kind of okay. It's a bit on the high side, to be honest. But the 12 volts is actually still, I would say, still on the low side. I'm not too familiar with the Color Classic, so I'm not entirely sure whether that's supposed to be like that or maybe there's something else. The thing is, I can't really adjust the voltages independently, so, to bring the 12 volts to 12 volts, 5 volts is going to be way too high, I guess. I would say let's leave a question mark on there. I will investigate online, ask maybe some other Color Classic owners, and we'll move from there. But for now, this is working. Though this time the Macintosh didn't reach the question mark and it's stuck in there, I'm not entirely sure why this is happening. I've got the Color Classic on its side so that I could access the floppy cable here for my Floppy EMU, as the Color Classic doesn't have a floppy connector at the back. So let's try and boot this Macintosh into an OS. Alright, well, it seems that something is going on here because I get this error message if I click OK. It comes back again in a second, and I've tried a few things. I tried different versions of the OS. There you go. I updated the firmware on my Floppy EMU. There's only like 1 or 2 mentions of these online, so I don't really know whether there's something wrong with the Color Classic, or just the Floppy EMU is probably not the best tool for this machine. So I think what I'm going to do, I'm going to move to the floppy drive and fully service it. We saw earlier on that it was in a horrible shape, but it's an Apple floppy drive, and those can be disassembled pretty easily, and they usually come back in a good shape. And then I guess I'll power on that quantum hard drive, and hopefully there will be an operating system on it, and that will allow me to move things around. But I understand that I can actually make 1.44 floppy disks on my Windows PC, so that should remove the floppy EMU from the equation, and we can confirm whether this is working or not, because right now I'm a bit stuck. But the good news is this has been on for a little while and everything seems to be working totally fine, so that's great. I've serviced Apple floppies on this channel before, so I won't go into too many details. If you're not familiar with the process, you just need to know that these drives can be fully disassembled. The carriage comes off, the heads come off, and everything can be cleaned and properly lubricated. It would have been nice if Apple had designed a system so that the floppy slot wasn't used as a ventilation inlet, letting in tons of dust, but the mechanism can be completely cleaned, so happy days. I will stop a moment on the eject mechanism though. For the first time, I found a broken gear, which is very normal for these drives, but never happened to my units. It's okay, I have spares. But when I went to inspect the gear and I saw that green blob, I was a bit concerned and I put everything under the microscope. And there, it looked even worse. It looked as if some corrosion had eaten away some of the brass motor cogs. I thought I'd lost the whole drive, but quite some scraping and rinsing later, the cogs reappeared intact and the drive was saved. That was interesting to see. The rest of the process involved removing all the plastic gears so they could be cleaned and relubricated, and finally reassemble everything. Alright, that was a difficult drive, but it's back in one piece and hopefully it works. So let's power up the Macintosh. Power on now. Oh yes, it moved. Okay. I wasn't expecting that. So the head went to track 0, which is great. Well, we got an assembly issue here, so I'll have to look at that. It was working a moment ago. So the issue is that the eject mechanism moved from the don't move position, which is where I left it, which is here, to this position here. I'm not entirely sure why it happens. By doing that, obviously the frames are not able to move anymore, and and everything gets stuck. And I'm not entirely sure. I think the problem might be the little switch which is inside, but I cleaned it and I think I put it back in the right position. Unfortunately, I'll have to open basically everything to go back to it and understand what's going on. So I think I know exactly what happened. It's actually quite funny. This is the eject mechanism, and this metal pin is the one that actually moves the frame, so ejects actually the drive. Now, the logic board knows that the pin is in the final position, which is here and nowhere else, by this little switch here. There is a plastic cam inside these, let's call it gearboxes, no gears, but anyways, and this cam is pushing on this metal part. It opens the circuit, and the logic board will know that the pin is in its final position. Now, for the pin to be on this position here, so facing me, which is the final position, the cam has to be on the other side. Otherwise, the cam will stop here, which is when it pushes on the metal contact, and the pin will end up on the wrong end, and the frames will be locked in place. So how did that happen? I just mounted the cam the other way around. Now the thing is, I've reinstalled a few of these mechanisms and I never realized that this could be installed the other way around. So I just need to remove it and flip it 180 degrees. But the thing is, all those drives that I've been servicing over time, they were installed correctly by chance. Because you have 50% chances that this is going to be in the right position. Anyways, let me swap this and I'm sure that afterwards it's going to be totally fine. Alright, take two, let's try again, and this time when I power up the Macintosh, the eject mechanism shouldn't move. Let's give it a go. 3, 2, 1, go. He hasn't moved, good sign. 50%. Alright, that's not a good sign. It's not doing anything, no! Oh, okay. Okay, well, I don't know why it didn't work the first time, but it's working now, which is a double surprise. It means that the driver that the floppy actually made on my Windows PC is actually working, so that's quite a few variables just clicking in place. Well, it's working! The floppy works totally fine, and we don't get that weird message about the initialization being failing, but that's totally fine. The mouse is a bit glitchy, the button doesn't work all the time, but it's working totally fine. I can see this Macintosh is reporting 10 megabytes of RAM. I think this is the largest that you can do on this board, at least officially. I haven't checked those RAM sticks, but I believe that's the maximum the board can do. So, yeah, that's great. Fantastic. I'm super happy with this. And the eject mechanism also works totally fine. Really happy we are making progress. Considering this Macintosh can only run System 7.1 onwards, I think, and also I cannot run the HD20 from my Floppy EMU, I think the next step would be to test the hard drive. Running everything from the floppy is very slow, and also it's quite limited because there's not much that you can fit on one floppy. I mean, the 7-point-something operating system comes on many floppies. So let's test the hard drive, let's hope it works, so that we can reinstall the operating system and then some diagnostic tools and start testing things. The hard drive is ready. I've managed to connect it outside of the case, so you know, if it's doing weird things, we have it in front of us. Will it work? Let's give it a go. 3, 2, 1, go. Oh gosh. It's dead, Jim. The drive is completely dead. It refuses to spin. I guess it fails some self-test or something. These drives are known for failing, so really not much I can do about that. But now, how do I run this Macintosh without a hard drive? There's really not much I can do. And I haven't got another hard drive. I mean, I think the one inside my Macintosh SC might work, but I didn't want to use that one, so let me see if I can find an alternative, a quick alternative, just to test this Macintosh. I opened the drive to inspect it. Apparently those old Quantums are known for getting the head stuck. I was told I had to push the head actuator while the drive was spinning up. The arm freed up, but the drive was still failed to initialize. I suppose this heavily disintegrated rubber bumper might be the cause of the problem. The heads are allowed to move too far, and the drive is unhappy. So I reluctantly got the even older Quantum out of my Macintosh SE and used it for a test. The SE was on 608 and the Color Classic cannot run anything lower than 7.1, so I painfully upgraded my hard drive to 753 using physical floppies, as the Floppy EMU would still refuse to work. I used a USB drive on my Windows laptop and I wrote all 16 floppies required for the 753 installation, overwriting those floppies as I proceeded. Well, the upside is that was a good test for the floppy drive and the system itself. Everything worked well, though it was painfully slow, and I reached the end of the installation with no errors. However, when I restarted the Mac, the system froze while rebuilding the desktop, and a further reboot produced more freezes or error messages. Though when I started the Mac without extensions, by holding the Shift key while booting, I ended up on a desktop and everything seemed to be working okay. So I thought I had it sorted and maybe it was just a matter of finding which extension was causing the issue. It was lunchtime, so I decided to take a break and continue later. I came back from lunch hoping to finally do some testing on this computer, install some software, run some diagnostic, make sure everything is okay, and start thinking of finalizing the system, putting it back together, and close this project. Now, unfortunately, when I booted up again, it would still refuse to boot. It would either come up with an error message or it would just freeze either at the desktop or just before the desktop. And at some point, even by holding Shift, so by disabling the extensions, it would still refuse to boot properly, it would still freeze or come up with an error message. It was literally getting worse and worse before my eyes, which is something I've seen before with these old electronics, especially when not properly stored. You fix one problem and then slowly but surely you see something else coming up, or it dies again and you have to fix something else. I think there are a few videos on this very channel where this happened to me. As you can imagine, I started troubleshooting, I started thinking what could it be. The first thing I tested was the RAM. This computer comes with 10 megabytes of RAM, 4 are on the motherboard and the rest are on sticks. So I removed the sticks. So if you remember, we replated the contact, so I thought, well, hopefully it's just an issue with the contact or with the sticks themselves. But unfortunately, it was still refusing to boot, it would still come up with an error message at some point of the booting process, or it would just freeze on me. Then I thought, what about the hard drive? Let's remove the hard drive and let's try and boot up from the floppy. And surprisingly, it would boot up totally fine and I could end up on the desktop and I could work on the desktop and it seemed to be totally fine. So I thought maybe there's an issue with my hard drive, maybe there's an issue with the hard drive circuitry of the board. Now the problem with this is I've got plenty of unknowns, plenty of variables, because I haven't got another system, I haven't got another hard drive, I haven't got more memory, I haven't got another logic board, so it could be anything, to be honest, and it's not easy to diagnose when you're in such situations. But as I said, the system was working totally fine from the 753 floppy, and I turned on the computer like 2 minutes ago before starting this video, just to show you, yes, everything is working, all is good, and he hasn't even posted, he hasn't done anything. It's been on a grey screen since I started, and I thought, well, I can show my viewers that it's got even worse now. I'm assuming that if I'm restarting it, it might work, but clearly we have a problem here. It's now booting, so maybe this is something that can be diagnosed with hot air and cold spray. So I'm thinking of ending the video here, because obviously this would require a little bit of extra time and it's not going to be like a 5 minutes job. We've done quite a lot today. The computer was completely dead and now it's, well, I don't want to say it's working, but it's kind of working. The logic board is working-ish. The analog board has been working flawlessly over the past few days and never had an issue. The CRT seems to be fine. I'm hoping this darker patch here you see on the bottom left can be resolved as soon as I replug the degaussing coil. But anyways, I will need to diagnose a bit more on this computer, and I think I'm gonna make another episode about that, otherwise this one gets too long. I would like to thank all the Tinkerdifferent Discord users. Thank you very much for, keeping me company, helping me with this, pointing me to the right direction, because I know up to some point with those older Macintosh, and this is the first time I have a Color Classic, so there are many things I don't know. So thank you again for your time. It's been fun to, have a laugh together and, explore all these issues together. Let me also thank Mike, aka The Tech Knight, always happy to help when it comes to Macintosh. Thank you very much for your help, Mike. It's always nice having a chat with you. So I guess that's it for today. We'll pick this up next time with some fresh ideas and hopefully with some new tools. I hope you enjoyed this video. If you did, as usual, I'd appreciate a thumb up down below, and also consider subscribing to this channel if you like this kind of things. You can follow me on Twitter, and I'm also on Patreon. The links are down below in the description. My Patreon's names are scrolling by the side of the screen. Thank you very much for your support. It's absolutely fantastic. You can also join me on Patreon for free. There is a free tier, but if you don't feel like joining Patreon, which I can completely understand, you can buy me a coffee if you want. The link is also down below in the description. If you don't want to buy me a coffee, which is totally fine, just watching this video, maybe leave a comment and a thumb up. If that would be fantastic, and I also appreciate that too. Well, that's it for today. Thank you for watching. I wish you a great day, and I hope to see you again soon here on my channel for my next videos. Thank you very much, and goodbye. Bye bye.